Good afternoon, students. This one is for period 2, semester 2 geometry, the pretest analysis. So just want to go through each problem here. So some of those are quite similar, so probably not spending too much time with the similar problem, but just want to go over like different type of problem here with variety process. Okay, we'll take a look at this. Okay, so the first one, which of the following term is best described as the point halfway between the endpoints of a line segment? Again, the keyword, so this one, just look for the keyword halfway between the endpoints of a line segment. So obviously it's the midpoint. Midpoint's right here in the middle of the line segment. Okay, so the next one, which of the following statement best describe the midpoint of a line segment? It's the point halfway between the endpoint of a line segment. It's quite similar to the first one. And also this one is a midpoint definition. So now here's the way to find the midpoint of a given line segments. So the formula for that is consider x1 plus x2, the sum of x1 plus x2 over 2, comma, and then y1 plus y2 over 2. So I'm going to do it on the difference on the other software here. So let me just highlight this one. Okay, so let's see. Okay, let me get rid of this one here. So the way to find a midpoint. Okay, so I need a graph as well. Okay, let me go back to the graph. Let me just highlight the whole thing here. Oops, paste. Wait. Okay, sorry about that. Okay, copy image. Paste. Okay, so the way to find a midpoint. So what we need to do. So it's all about the formula. So the way to find a midpoint, it's x1 plus x2 over 2, comma, and then y1 plus y2 over 2. So what we got here is negative 3, 5. So from left to right, so we got first point, x1, y1. Let's just label it. So start to give some name for the points. And then the other one is called x2, y2. So basically what you need to do is just plug in a number to find the midpoint. So x1, which is negative 3, plus x2, so 5 over 2. And then y1 plus y2, so we got 5 plus 5 over 2. And you want to do it mentally, negative 3 plus 5, so then that'll be 2. And then 2 over 2, which is 1. And then 5 plus 5, 10 over 2, 5. So 1, 5, which is right up here. And that will give you the midpoint. Okay, so now let's see what else that we have for the next one. I'm sure that's going to be quite similar. Again, this one also, so using the midpoint formula, you try to do it mentally. So negative 6 plus 10, then that'll be 4 divided by 2. So the x value for the midpoint would be 2. And then the y value for the midpoint, so y1 plus y2 over 2. So what we got is a 3 plus 3 over 2. So then that'll be 3, so 2, 3. So again, we're using the midpoint formula. So x1 plus x2 over 2, comma, y1 plus y2 over 2. It's just like the way we find the average value of two numbers. Okay. And let's move on to something else. So question number 3. So what's the midpoint? So using the same kind of formula, we can get that. It doesn't matter what kind of line that you deal with. You know, the line, whether that's straight, horizontally, vertically, slanted, so we use the exact same midpoint formula. So let's do the one with the vertical line segments. So you know what? I'll do 3C. So it looks like that one is going to be like a fractions for the final solution. So what's the midpoint of the vertical line segment graph below? Okay, so let me just copy this. Okay, so copy and paste. Okay, so now here's the one. So let's find a midpoint. Okay, so from 1, 4 to 1, negative 5. So what we got here, according to the given xy coordinates, so we do have x1, y1. And for those students might be wondering, can I start with the bottom one as x1, y1? Certainly you can. So the next position would be considered x2, y2 then. So what we got here, according to the formula, x1 plus x2 over 2, open parentheses, comma, y1 plus y2 over 2. So what we have here is 1 plus 1 over 2, comma, y1 plus y2, so 4 plus negative 5 over 2. So for the x-coordinate, we got 1. For the y-coordinate, we do have negative 1/2, or negative 0.5. So the answer for this one would be 1, comma, negative 1/2. So it's choice D. Slanted line, so quite similar. So let's do this one. So using the midpoint formula, once again. Okay, copy and paste again. Okay, so slanted line segment. So again, the way to find a midpoint, identifying the number. So x1, y1. Yeah, let me switch the mode back to pen. There we go. x1, y1, x2, y2. So what we got here is negative 12 plus 5 over 2. So whatever the x value that you have, combine them together, divided by 2. For the y coordinates, so we do have negative 3, negative 10. Once again, combine them together, divided by 2. So negative 12 plus 5, we do have negative 7 over 2. Negative 3 plus negative 10, so then that'll be negative 13 over 2. Okay, so let's go back to the solution, what we found here. That's right, so negative 7/2, comma, negative 13 over 2. So now let's skip all this slanted line. Doesn't matter what kind of slanted line that you have. The way to find a midpoint, it's always using the same midpoint formula. So this one can skip all the way down to distance formula. So in order to find out the distance in between 2 points, we need to apply the distance formula. Okay, so let me just copy and paste this one again. Okay, so let me just put it down here on the bottom. Oops. So the way to find the distance between 2 and 2 comma 3 and 4 comma negative 3. Again, first thing that you want to do, identify the point first. So what we got here is x1, y1. And then x2, y2. So the distance formula, it's a little bit different. So square root of the quantity of x2 minus x1. Got to be careful with the notation. So x2 minus x1 quantity square plus y2 minus y1 quantity square. So the distance formula. So what we got here, so x2 minus x1, so we do have 2 minus 4 quantity square, or 4 minus 2, you can do it either way. So let's just follow through the order. So, excuse me. So this one here will be considered x2 minus x1, so we do have 4 minus 2. And then y2 minus y1, so negative 3 minus 3 quantity square. So 4 minus 2 quantity square, so 4 minus 2, that's 2, so that would give me 2 square. Negative 3 minus 3, so that would be negative 6 quantity square. So we do have 2 square, which is 4, negative 6 quantity square, 36. So we do have square root of 40. So square root of 40, so try to break it apart into a perfect square number, non-perfect square number, we do have 4 and 10. So the answer can be written either like root 40 or 2 root 10. If we try to simplify it all the way through. Okay, so now let's go back to the selections. Oh, this one is just the setup. So we just need the setup. So it's C. And then for 6B is quite similar. So 6C is also quite similar. So what about for number 7? So this one we need to find out the exact unit of the distance between those two endpoints. So now let's try this one here. Again, it's quite similar to the one that I showed you. Okay, let me just put to the next slide here. So copy and paste. So what's the distance between the points 2, 10 and negative 6, 4? Again, so in case that you're going to confuse yourself, so let's just identify the positions, the point. So what we got here is x1, y1, and then we have x2, y2. So using that, the distance formula. If you're not quite sure what that is, it's better for you to write it down first. Okay, so y2 minus y1 quantity squared. And now we just plug in a number, x2 minus x1, so negative 6 minus 2. Again, this time we need to find out exactly, the unit, the final solution for the distance. So y2 minus y1, so we got 4 minus 10, quantity square. So negative 6 minus 2, so we do have negative 8, quantity square. 4 minus 10, negative 6, quantity square. So negative 8, quantity square, negative 8 times negative 8, what is that? 64. Negative 6, quantity square, so we do have 36. So the sum, which is what? It's 100. So the final result is a perfect square number, which is what? 10. Okay, going back here, so it's 10 units. Again, if it doesn't have any unit like meter, centimeter, miles, inches, sometimes, the solution wanting to put in a unit, so we'll just put in 10 units. And 7b is quite similar, 7c is quite similar, so we can skip all that. And what about for A? So this one looks like it's not a perfect square number and you need to round it off. So again, using the distance formula and just put it into the calculator. So this one is about 7.07 unit. Again, so for number 8 and all those questions, looks like the distance cannot be, it's not going to be a perfect square number. So this one you have to round it up. Okay. So for number 9, so number 9 is about the linear regression. So using the graph below, what's the best estimate of hour rate a person earns for 5 years of experience? If the equation for the line of best fit, it's y equals 1.3x plus 5.5. So x is representing the number of years of experience. And the result y, which is the hourly rate. Okay, so what we got here is y equals 1.3 x plus 5.5. Okay, so again, copy and paste. So one thing that we do notice is that the value of x, which is what, 5 years. Okay, so again, any time that you see the word problem like this with the graph, always highlight a key number or the key phrase. So that's just the x value. And here's the model we have. It's a linear regression model. So 1.3, which is showing that the slope, 5.5 is showing the y-intercept, like the initial starting point. Okay, so what we can do here, so we can start it with that y equals 1.3 by plugging a number, so times 5 plus 5.5. So 1.3 times 5, so 3 times 5, 15. 1 times 5, which is 5 plus 1, so 6.5 plus 5.5. So eventually it's going to be considered 12. Okay, so let's take a look at that. So it's $12 per hour. So for the final rate. And the rest of this is quite similar. So whatever the x value that you have, so just plugging that to the linear regression model, and then you calculate the y value. If you need a calculator, you can always use a calculator for this. And now let's skip through number 10. Okay, so this one is showing the graph. And what's the equation of a line graph below? So anytime that you see the graph like this, it's always considered the slope-intercept form. So the slope-intercept form consists with y equals mx plus b. Okay, so let me just highlight the problem with the graph right here. Okay, so copy image. So what we got for this one? So as you can see that the y-intercept here, it's 0, 0. So let me just label that. So it's right here at the origin. And one thing that we noticed, the linear regression model is always mx plus b. And it's also called the slope-intercept form. Those who were taking Algebra 1 last year. And so y for this one would be considered the slope. So the way to calculate the slope, we can do this, rise over run. So start at the origin. So the rise would be 2. And then the run is 1. So up 2, 1 over to the right. So the slope is 2 over 1. And then the y-intercept, so which is 0. So that means the final equation is 2x. That's it. Another way you can find the slope is by using the slope formula, which is considered y2 minus y1 over x2 minus x1. So since we do have 2 points, so we can use that the slope formula. So y2, well, we'll just label it. So 0, 0, that's x1, y1. 1, 2, so that's x2, y2. So using the slope formula, so we do have y2 minus y1, so 2 minus 0, over x2 minus x1, so 1 minus 0. And then divide it, so we got 2 over 1, which is 2. And then once you find the slope, just put it into the slope-intercept form. So this one is actually pretty straightforward. It's not, well, actually, it's algebra 1. So something that you guys did last year or 2 years ago. So here's what we found. And then the next one is quite similar. You can always calculate their slope, but one thing you need to watch out, the line is going from left to right. It's declining. So that means the slope is negative. So the answer would be C. And this one, the line is increasing, so going from left to right. So anytime that you want to read through the graph, so I just want you to point out, it's always from left to right. We don't read through the graph from right to left, okay? So calculate the slope, rise over run. So pick the y-intercept at the origin. And then calculate that the rise and the run. So we got the slope is 5. So the y-intercept once again at 0, so it's 5x. Okay, so 11 is quite similar, so we can skip all that. It's all about finding the slope or finding the equation of a line. Okay, so now what about number 12? So which statement best describe a line in slope-intercept form when the coefficient of x term is negative? So if x term, the coefficient is negative, that means the slope is what? It's negative. So if the slope is negative, that means the line is slant down, okay? So the line is slanted, it's going down. So the answer is D. And which statement best describe a line in slope-intercept form when the coefficient of x term is positive? So that means the line is increasing. So that means the line is slanted up. And which statement best make about a line in slope-intercept form when the graph of a line appeared to slant downward from left to right? Slant downward from left to right, so that means the x coefficient is negative. Which of the following is best definition of slope? Definition of slope, it shows that the steepness of a line, rise over run, or sometimes being considered delta y over delta x, and which term can be defined as the steepness of a line, so that's a slope. Okay, so just want to check one thing, making sure that, okay, good. Okay, so another way to describe the slope, rise over run. Okay, so what type of slope is demonstrated by the line below? So anytime they see the horizontal straight line, the slope is always considered 0 because that line is flat. It doesn't show any kind of steepness. Another way you can find the slope from this line here, you can always use the slope formula, which is y2 minus y1 over x2 minus x1, the one that I showed you earlier today. Again, if the line is flat, straight, so there's no steepness, so that means the slope of the line is always considered 0. So now let's move on to the next one. And what about if that's a vertical straight line? If that's a vertical straight line, that means the slope is undefined because that the vertical line, it shows just like a perpendicular straight. It doesn't show any kind of steepness also. So this one is undefined. And what about the line is slanted? And it's slanted from left to right, downward. So this one is a negative slope. Increasing, so it shows that the line So it shows like increments from left to right, so that means the slope of the line is positive. If you just calculate that rise over run, or you can use the slope formula, you'll get 4 right here. So y2 minus y1, so you can do that 3 minus -1, you get 4. And then -1 minus -2, you get 1. So 4 over 1, which is 4. So same thing happened with this, using the slope formula to find the slope of a line. Okay, let's skip all of that. Now, what happens if the triangle is given? How do you find the slope of the ram? So in order to find the slope of the ram, it's all about the rise over run, as what we mentioned earlier. So rise for this triangle here is 2, the run is 5, but this one is going from left to right. As you can see that the slope of this line segment here, so it's increasing from left to right. So the slope would be considered 2 over 5. And what's the slope of the ram show right here? So this one would be considered 1/3. Again, rise over run. And also the line is increasing from left to right. And what about the slope is declining? So that means the slope is going to be negative. So this one would be considered -3 over 10. And 18, so which graph shows the line y equals 2x plus 3? So it's 2x plus 3, that means the y-intercept we need to start at 3 on the y-axis. So let's just calculate it. So either the red one or the green one, but the slope is positive 2. So the slope is positive 2, that means the red line right here. So the answer is D. And here's another one, y equals -3x plus 1. So started with the y-intercept. So let's just allocate the y-intercept. So it's either the green line or the blue line. And the slope is -3, so it's going down, -3 units down. So it's going to be the green line right here. So which is what? B. And the next one is quite similar. So started with the y-intercept first. The y-intercept, one thing you need to watch out, the sign is also considered part of the y-intercept. So the y-intercept here would be -2. So a lot of people kind of confused saying that y-intercept is 2. So they probably pick either the purple or the green line, but it's supposed to be down here. So -3, -2. So it's either the blue or the red line. And also the slope is positive, so it's the blue line. So it's A. If you see the point slope form like that, so that means first thing you want to do, you want to simplify the whole thing. So let's do this. Okay, so let's do some analysis here. Once again, I'm going to copy and paste. So if the structure of the slope-intercept form is getting a little bit complicated, so one thing that you want to do, you want to simplify the whole thing. So what we can do here is we can just multiply it out, the right-hand side. So we got y minus 1 equals 2x plus 4, distribute. And then we do have y equals 2x plus 5, because you want to add 1 both sides here. So what we found here is the y-intercept form, or the slope-intercept form. So as you can see that the y-intercept, which is 5. And then the slope, which is 2. So going back to what we found, so the y-intercept is 5, so it's either the green or the blue line. But the slope is what? 2. So the answer would be C. Again, anytime they see the point slope form given like that, always multiply it out, combine the like term. So you want to convert that from the point slope form to the slope intercept form. So find the y-intercept first, and then determine the slope. So once you get all those information, we can sketch the graph for the line. Okay, so now let's move on to this one right here. So what about the slope-intercept form is given? Find its slope. So the slope is always the coefficient of the x variable, so it's -2. And the slope of this line here, 1/2, quite obvious. So -3. And the y-intercept is always the constant. Again, the sign is also part of the constant, so make sure that you pick the whole thing. So the y-intercept, 7. Y-intercept for number 21b, 1/2 x minus 5, so the y-intercept is negative 5. Okay, so now let's see, what about 22? So what is the equation of a line with a slope of 6 and y-intercept? So basically just plugging that to the slope-intercept form. So we got 6x minus 2. And this one right here, so what we got here is negative 3x plus 4. Okay, so 23. If a line has a slope of 2 and contains the point negative 2, 1, what is the equation in point-slope form? So now let's do this with another slide. So let me just copy and paste. Okay, so this one here, you want to show a little bit work on the other piece of binder paper. Oops, again, I did the wrong thing here. Okay, one more time, copy and paste. Okay, so now what we found here, so the slope is 2, and the given point, it's negative 2, 1. So let's just identify the given element, so negative 2, 1. So let's say this one is x1, y1. So for the point-slope form, as you may notice, so it's y minus y1 equals m times the difference of x minus x1. So again, this one is called a point-slope. So what we have here, so the slope, so just plug in a number, so 2, x, we don't know what that is, but we do know x1, so it's minus negative 2. And then y minus y1, then that'll be minus 1. Try to simplify the whole thing a little bit, so we got y minus 1, so that equals 2 times the quantity of x plus 2. Because negative times negative, which is positive. So going back to the selection, so what we found here, it's C. And 23 is quite similar. So again, the slope is 3, the given point. Plug in a number and then try to simplify that a little bit. Okay, so now let's move on to 24. What's the slope of the line representing? If you try to simplify it to the slope-intercept form, this one, it tells you the slope already. It's the number outside the parentheses here. So which is what? 2. It's quite obvious. Negative 4, slope. Okay. And now what about for 25? So here's what I would like to talk about for 25, 26, 27. So one thing that you may notice, if two lines are perpendicular, so that means the slope got to be negative and reciprocal. If two lines are parallel, that means the slope got to be exactly the same. So make sure that you guys recognize the relationship. So the slope of the red line here, it's 5/2. And what's the slope of the green line? So try to convert that to the negative reciprocals. We do have positive 2/5. Okay, so this one, the red line, the slope is negative 7. If the denominator is not shown, so that's always 1. So what's the slope of the green line? Then that'll be positive 1/7. Okay, so 25 is quite similar. So negative 4/3, negative reciprocal, then that'll be 3/4. Okay, so 26, it's a proof. Okay, let's see what we need to define here. So the proof is given already. And what's another way to summarize the outcome of this proof? Let's see what this person tried to prove for. Oh, you want to show the exact same slope. Again, if the slope of the lines are exactly the same, that means the lines must be parallel. So this one is answer C. So parallel lines have the exact same slope. And this one, you want to find out the missing reason for statement number 3. So this one showing that AX, okay, let me just enlarge a little bit. This one is possible. I can enlarge that. Okay, anyway. Oh, here we go. Okay, so AX, so that equals AX times DY equals BX times CY. So segment AX times DY equals segment BX times CY. And then try to simplify that. It shows like a ratios property here. And looks like something that can be simplified a little bit more. So this one showing that proportionality relationship. Since you're multiplying by something, so this one it would be considered multiplication properties of equality. So the reason would be multiplication properties of equality. And then 26, again, finding the missing reason. The slope of AB is y1 over x. Slope of CD is y2 over x. So this one is just like definition of slope. Question 27. So what's the equation of a line that contains the point 2, 1 and it's perpendicular to the line? Okay, so now this one is getting a little bit more complicated. And I'm sure a lot of people are having trouble with a problem like this in Algebra 1 and also in geometry. So let me just highlight this one here. Let's see. Let's try to do this. Just want to minimize it a little bit. Here we go. And then copy and paste. Wait, what's wrong? Okay, so 27. So again, I'm going to show this one on the Active Inspire slide here. Oh shoot, it's supposed to be paste. So now it's gone. Okay, one more time, copy and paste. Sorry about that. So what's the equation of a line that contains the point 2, 1? So the one that's given here is x1, y1. So what we found here, x1, y1. And it's perpendicular. So the perpendicular, we need to define the slope of the given line first. So the slope of the given line is 3. So if two lines are perpendicular, so that means the slope got to be negative and reciprocal. So that means the new slope is negative 1/3 with x1, y1. And don't forget about the point slope form that we have already. So by using the point slope form, we can set up the equation of a new line, the perpendicular line. So the new slope is negative 1/3, and then times the quantity of x minus x1, so then that'll be 2, and then y minus 1. So that's what we found, so the point slope form, but try to simplify it a little bit more. So we do have y minus 1 equals negative 1/3 x plus 2/3, so just multiplied it out. Add 1 both sides, because I want to convert that to the slope-intercept form. So you do have negative 1/3 x, and 1 is just like 3 over 3, 2/3 plus 3 over 3, we do have 5 over 3. Okay, so going back to the selection, so what we found here is C. So that was 27, and here's another one, so we can follow through the same kind of process and try to figure out the new perpendicular line. One thing I want to talk about, parallel. If two lines are parallel, we don't need to convert the slope to its negative reciprocal. We just need to use the exact same slope. Okay, let me show you this one here real quick. Okay, so copy and paste. This one's a little bit tedious. I need to switch the mode. Okay, so paste. Again, the given point, what we have here is 2, 1. So let's just identify what that is. So x1, y1. And the given slope is 3. Keyword, parallel lines. So two lines are parallel, that means the slope got to be exactly the same. So m1 equals m2. So we're using m2 equals 3. So using the point slope form, once again, so y minus y1 equals m times the quantity of x minus x1. So we do have y minus 1. And then the slope, which is 3. And then x minus x1, 2. So we got y minus 1 equals 3x minus 6. Again, what I'm doing here, just distribute. And then add 1 both sides. So we got y equals 3x minus 5. Okay, going back to the selections. So let's see what we have. That's right. So it's the answer D. So 27, it's quite similar. Again, two lines of parallel, so we do use the exact same slope. And for 28, in triangle ABC, a right triangle, how do you know? So if that's a right triangle, that means two line segments. The slope of those two line segments must be parallel. As you can see that AB and BC here, if you just find a slope here, you'll see that they're considered negative and reciprocal. So yes, because that slope segment AB times the slope of segment BC equals -1. So this one, it shows the negative reciprocal relationship. So the answer is C. And which of the following is not true if a polygon is a square? So the slope of the adjacent line segments are equal. Excuse me. The slope of the adjacent line segment, they are not equal for the square. And they're considered negative reciprocal. Okay, so now let's see what else that we have. And which statement proved that the polygon ABCD is not a rectangle? So if that's not a rectangle, that means the adjacent line segment, the slope of the adjacent line segment, they're not considered negative reciprocal. So the one showing that they're not equal to -1. So that which implies it's the non-reciprocal relationship. So the answer is A. So which condition is sufficient to show that the polygons are congruent? So it looks like this one shows some kind of sliding translations, the relationship. Okay, so the translation of all corresponding vertices of the polygon have the exact same rise and run. If you try to calculate that from A to A, we use the exact same slope. From B to B, we use from A to L, from B to M, we use the exact same slope. So this one shows that the corresponding vertices of the polygon have the exact same rise and run. For the triangles too, so it shows the exact same kind of translation. Again, so triangle ABC and triangle XYZ have the exact same orientation. So exact same orientation, that means shows the same kind of translation. Wait a minute. Which of the following condition is not sufficient? Not sufficient, that means it's showing that it's not good enough to prove they are considered congruent. So this one will be saying that the same orientations. Okay, so orientation, that means it's also including reflections. So obviously this one is not true. And then ABCDE is reflected over the x-axis, then translate 3 units left. So what are the new coordinate D? So the original coordinate D would be considered -3, -1. Okay, let me just copy down this one here, and then I'll show the analysis on a different slide. Okay. So once again, copy and paste. And also I need the diagram as well. Copy image. Okay, so we're looking for the new coordinate, D prime. So it's reflected over the x-axis. So we do know that the relationship for the translations. So starting with that x, y, so reflected over the x-axis. So that means we need to consider changing the y value to its negative. So this one is the formula for the x-axis reflection. And it's also showing that's the translations. So 3 units to the left. So 3 units to the left, that means it's considered going to the negative direction. So it's x minus 3. So x, y goes to x minus 3, y. So let's start out with the reflection first. So we do have point D, which is -3, -1. Okay, so we just need to follow the first process and then the second process. So according to the formula, we do have x, y. So we do have -3, -1. So then that'll be +1. Again, we don't change the x value. It's reflected over the x-axis. That means going back to this position here. And now it's translated 3 units to the left. 3 units to the left. So whatever the x value that we have, we need to subtract that by 3. And then the y value, we just want to keep the exact same number. So eventually, the position is going to be moved to -6, 1. So again, 3 units to the left. So it's going to be right here. So we got d prime. Let's say this one is d prime. This one is d double prime. So it's the reflected, and then it's translated. Okay, so now let's go back. So the answer is -6, 1. So that's what we found. And then the next one, so reflected over the x-axis, translate 3 units to the left. So this one is quite similar. So just use the exact same formula for this. And also the other one too. So now if the rectangle below has an area of 32 square unit, what's the area of a triangle? So one thing that we notice, the area of a triangle is always half of the area of the rectangle. So the area of the rectangle is 32. So that means the area of the triangle, it's half of it. So it's half of 32, which is what? 16. Another way you can find the area of a triangle is base times the height divided by 2. So 4 times 8, 32 divided by 2, 16. And this one, finding the area of the triangle, so base times the height divided by 2, so we do have 20 square units. The other one's quite similar. Okay, so this one, just finding the area of the figure. Okay, so the area of a triangle, so we just skip all this. So for the obtuse triangles, so similar, so area, base times the height divided by 2. So 6 times 15 divided by 2, then we'll get 45 square units. Okay, so area of a triangle, base times the height, so 18 times 5 divided by 2. So 45 square units. Okay, so what about the problem like this? So what's the area of a triangle formed by the points? So what you need to do, you want to find the distance of all those segments. And then once you get the line segment, the distance, so you can use the formula, area of a triangle, half times base times the height. So what you need to do, you want to plot the point first, find the distance of the line segment. And it looks like the base for this one would be considered 3. And the height. So it looks like you still need to find the height. So once you get the base and the height, so multiply them and then divide it by 2. So again, plot the points first, and then find the base, find the height, and then use the formula for the area of a triangle. And what about a trapezoid? So let's do this one on a different slide. So the way to find the area of a trapezoid. Okay, so once again, copy and paste. And also I need the diagram as well. So what we got here, so the upper base, the lower base, and the height. I cannot really read that number, so let me go back to this one. So the upper base, we do have 7. Bottom base, we do have 19, so the height is 6. So the way to find the area of a trapezoid, so it's always considered base. The way to find the area of trapezoid, it's 1/2 times the quantity of B1 plus B2. B1 is the upper base, B2 is the lower base. And then times the height. So it's 1/2, B1, 7. So B2, what is that, 16? No, 19. And the height, which is 6. So 1/2 times 6, we do have 3. 7 plus 19, we do have 26. So 3 times 26. So 6 times 3 is 18, 3 times 2 is 6, so plus 1, so 78 square units. And the way to find the area of a parallelogram is always base times the height. So the height is always perpendicular from the upper vertex to the bottom base. So the height is 4, and looks like the base would be 12, because parallelogram, the upper base and the lower base are exactly the same. So 12 times 4, so base times the height, so we do have 48 square unit. And the way to find the area of a rhombus, okay, so let me just highlight this one. So the way to find the area of a rhombus, it's always consider 1/2 times d1 times d2. What I mean by d1 and d2, so d1 is called the main diagonal, and d2 is called the minor diagonal. Okay, so we'll take a look at that. So I have to do it twice, so the instructions and then copy the diagram. Okay, so here's what we found. So again, so what I mean by d1 and d2, so this one is considered d1. And here's another diagonal, so d2. So the picture is not that clear. Let me go back to the original one. So what we found that the main diagonal, it's 20. The minor diagonal is 15. So this one is just 1/2 times 20, which is 10 times 15. So then that'll be 150. Okay. So 150 square unit. So again, the way to set it up, area. So it's 1/2 times d1 times d2. So it's 1/2 times 20 times 15. So 10 times 15, so it's 150. And it's square unit. Okay, so now let's see what else that we have. Almost getting there. Finally, a polygon. So let's see what kind of polygon this one is. So count the size. So starting from here. So 1, 2, 3, 4, 5, 6, 7. So 7 size figure. So this one is called the heptagon. So now let's see what kind of problem this one is. Which of the following best describe the dashed line showing the regular heptagon below? So from the center of the polygon to the midpoint of the bottom base. So anytime they see the dashed line segment like this one is called a apothem. Again, definition of apothem is from the center of the polygon to the midpoint of the given base of a polygon. So it's called apothem. So here's another apothem. So this one looks like it is an octagon. We don't call it altitude, okay? So altitude, we use that to describe the height of the regular quadrilateral. Quadrilateral, that's a 4 size figures such as trapezoids, square, rectangles, parallelogram, rhombus, things like that. Or kite. And here's another one, so the apothem. So 39, so what's the area of a regular heptagon? Okay, so let's see. Once again, I want to copy down the whole thing here, if that's possible. So it doesn't allow me to do that. So let me just copy the instruction first. Okay, again, copy and paste. So the way to find the area of a polygon, if that's a regular polygon, regular, that means all sides are equals, all interior angles are equal. Okay, so copy and paste. And this way you need to round it, so that means you have to use a calculator. And also the diagram that I have, so this one it's a heptagon. Again, the reading is not that clear, so I need to go back to the original diagram. So the apothem is 23, and then the base is 22.15, okay? So let me just write it down here. So the apothem is 23, and then the bottom base, 21.5. Wait, 22.15. Okay, so bottom base. So the way to find the area of the regular polygon, it's always 1/2 times the bottom, and then times the perimeter of the entire polygon. So since we do know that it's a heptagon, so it's a 7 equal sides. So what we got is 1/2 times the bottom, 23. So again, basically just plugging the number. It's actually pretty simple. So perimeter of this heptagon, so then that'll be 7 times 22.15, because each side is 22.15 in order to figure out the perimeter, so we need 7 of those. So 7 times 22.15, and try to do that on the calculator eventually. So let's see what we can come up with this. It's about 1,783 square units. So again, the way to find the area of a regular polygon, it's always 1/2 times the bottom times the perimeter. And for those you might be wondering why that is, okay, so here's the reason why. So you try to cut it off into like an equilateral, well, not equilateral, isosceles triangle, so you have 7 of those. So we got 7 of those isosceles triangles. So 1/2 times 23 times 22.15 is just the area of each triangle. And we got 7 congruent triangles, so that's why it's 1/2 times 23 times 22.15 times 7. Okay, so now let's see what else that we have for the rest of this. So this one, what is that? It's a similar problem, but it's finding the area of a pentagon. So it's the same strategy, 1/2 times 1.62, the bottom, and then times the base. And we need 7, well, not 7, pentagon, penta, that means 5, so multiply by 5. So again, 1/2 times 1.62 times 2.36, and then times 5, so you got about 10 square units. And now what about for number 40? So we do know that this one is a composite figure, and this one, according to Apex, this one is called an irregular polygon. Okay, but the appropriate noun for that would be considered a composite figure. Composite figure consists with different kind of shapes. So we do have a rectangle, and looks like we do have 2 congruent triangle here. The one on the left and the one on the right. So the way to find the area of this, so first thing that you want to do, find the area of the center rectangle. So 18 times 4. So you'll get 72. And then the area of a triangle looks like this one. It's a triangle. What kind of triangle is that? It looks like it's an isosceles triangle. That was an equilateral triangle. So 4 times 3.5 times 1/2 and times 2. So 1/2 and 2 got canceled. So basically this one is actually pretty straightforward. Okay, so let me just highlight it again. So we just need to find the area of those 2 triangles and then the area of a rectangle. So once you get those area, we just need to combine them together. Okay, so we do have 18.4 and 3.5. Okay, so this one, oops. 18 and 4, so the height, which is what, 3.5? Just want to make sure that this one is correct. Yep. So the way to do it, so find the area of the rectangle, so 18 times 4, and then the area of those 2 congruent triangle, we just need to find one of those and then multiply by 2, so 2 times 1/2 times the height, 3.5, times the base. So this one is just length times width, and then plus 2, because we do have 2 identical triangles. Half times the base times the height. So 18 times 4, which is what, 72. And then 2 and 1/2 got cross canceled. 3.5 times 4, so 3.5. So just like what? 7 times 2, which is what? 14. 72 plus 14, so we do have 86. So it's about 86, is exactly, not about, exactly at 86 square units. Okay, going back. And now the composite figure. So find the area of the rhombus first, and then find the area of a square. So the area of a square is quite simple. It's 5 times 5, 25. Area of the rhombus. Got to be careful with that. This one, half of the segment is 4, so the entire segment is 8. So this one's 3, so the entire segment is 6. So 8 times 6, 48. Divided by 2, so we do have 24. 24 plus 25, so it's, which is what? 49. 49 square units. So here's another one. So find the area of the pentagon first, and then find the area of the rectangle. Combine them together, so eventually it's 121.5 square units. And the rest of this, so what's the perimeter of the polygon? So it looks like this one, well, if this one is a irregular polygon, so that means you need to find out the line segments. So the way to find out the line segment, it's about using the distance formula. So once you get all the distance of the line segments, guess what? All you need to do, just add them all together. So eventually it's about 21.6 units. So perimeter, that means it's all sides together. So the surrounding size of the figure. So once you find out the distance of each line segment, so you just need to add them all together. Same thing happened with this, irregular polygons. Find the line segments by using the distance formula. And then add all the distance together. So eventually that's 21.7 units. Similar to this one, 42. Okay, so this one's quite obvious. So it looks like kind of like a rectangle. Again, find the distance of the line segments, combine them all together, so 26 units. And 24, so similar. Find, well, this one is not finding the perimeter. This one is finding the area. So you just need to find the length and the width. Those two distant, and just multiply them together. So it looks like the width here would be considered 13. 13 times 2, 26. 4 times 5, 20 square units. Again, so find the length and the width using the distance formula, and then length times width, you'll get the area of the polygon. Alright, that's it. So again, any questions, so any concern that you have, so please let me know. And you're more than welcome to watch the video more than once, okay? Always rewind, going back to the one that you were struggling. So far, Unit 1 for both classes, they're pretty straightforward. Okay, so I don't see any like a major concern. Again, if you know exactly what you're doing, so you can skip through all the practice, and you can just go through all the sections quizzes. So once you getting ready for the chapter or the unit test, so please let me know. So on Thursday, we're going to be doing that all together, and I'll try to monitor the whole class with the unit test, either the unit test or the CST. So I'll give you the plenty of time for that. So probably about like hour, 1.5 hours, or 2 hours for the chapter test. Okay, so I'll see you guys next time.